way over to here, but it could also go, how about this one, all the way over to here? We have 2. This now is my reference angle. If this is 2 pi, what's my other one? 2 pi minus that, so 11 pi divided by 6, okay? So what are we trying to find? You know, we get so involved with finding stuff like this. Let's go back. What are we trying to find? Critical numbers. How are we finding those critical numbers? We're asking ourselves first, what's the derivative? And then we're saying the derivative equal to 0. Setting the derivative equal to 0. Okay, we found that by going through the secant route, we actually could come up with factors that helped us. Could you have found your way through this? I think you could. You'd have to make some changes on here, but you could have continued on that blue line also. So we come down to this. What are these? Critical numbers. I'm going to just abbreviate as CN. You may do the same. If you put CN, I'll know what you mean. Critical numbers. At critical numbers, we have what? Therefore, the function has extrema at theta equaling 7 pi divided by 6 and theta equaling 11 pi divided by 6. So now do we know if it's maximum or minimum? Well, we can take a look at the function and decide that by graphing this. So let's see, our function, if you are, well, let's see, we'll start, get out of this. We'll do that. Okay, another graph page. If you're on the gray model, you're going to have to convert secant to 1 divided by cosine. So we'd have 2 times, I'll put a fraction in here, 1 divided by cosine, and I'm going to make it cosine x so I can see the graph here. And then I've got times, and I want, or excuse me, plus, so let's put a plus there, plus tangent, and I do have tangent here, so I can just do tangent x. Now we're on the interval from 0 to 2 pi. Did you notice that? Are the critical numbers are in the interval from 0 to 2 pi? Yeah, they are, so we're all set there. If I look at this and I go from 0 to 2 pi, I'm going to change my window so I can really see that. So, oops, let's try that again. Okay, so I'm going to go from negative pi divided by 2, and 0 to 2 pi, so I'm going to go up to 7 pi, what am I thinking of? Divide by 2. I'm having a hard time today all of a sudden. We'll just do 2 pi. I don't need to think that hard, I guess. I'm going to scale it by this. I need to put in some minimum and maximum. I'm going to put in negative 5 to, oops, get my fingers on the right one. Negative 5 to 5, scale by 1. And I'm going from 0 to 2 pi. 2 pi is all the way over here. I'm looking for extrema. Where are my extrema? And it looks like I've got 1 here, and I actually have 1 here. If you go to menu and go analyze, and you look for a minimum, and we'll go from here to here, I can get a minimum. Go menu, analyze, and look for a maximum, and go from here to here, and I have my maximum. Now, are these values consistent with 7 pi divided by 6? I don't know until I check it. So I'm going to go into a calculation page, and let's see, I need 7 pi divide by 6. Is that about what I had on my 3.66? 3.667, okay? So if I check the 11 pi, it would also be then about 5.76. Okay. That's the type of problem you're going to be dealing with in this section. Given a function, determine critical numbers. Let's look at, graph a function on the interval from -2 to 5, having the given characteristics. Relative minimum, critical number but no extrema. We haven't talked about how can it be a critical number but no extrema. Absolute maximum, absolute minimum. I'm going to pause this. Brandon, would you show us what you looking at there? Oops. You're left-handed. I guess that's the right person. Okay, sorry. I don't know how you do. Who's right-handed? Erica, show us what she's got. You're right-handed. Yeah, sorry about that, Barbara. Just eliminating against you. Let's see what we've got here. Relative minimum at negative, is this -1 here? Yeah, okay. This would also be 1 though, wouldn't it? So you added an extra one?
Oh, it says relative.
Okay. Well, it's a minimum, so we'll make this be -1 here. Okay, we'll just say you had a -2 that you didn't know what to do with. Okay. Absolute maximum at 2. And an absolute minimum at 5. Now, if we're going to be cutting this off right at 5, we wouldn't have any of this on there, okay? And at -2, we wouldn't have any of this, so that's how we would interpret those pieces. Okay, but let's take a look at this, because what we have is this critical number, but no extrema. Now, I would have to question how would it be if I draw a tangent to this? Would that tangent line have a slope of 0? Okay, or is it undefined? Remember, it can be undefined and also then work as well as a critical number. Okay. So I agree with everything but that one piece. That one piece is going to be the one I'm looking for now. Anyone have something different? Okay. Akeem, you right-handed? Yeah. I think you might have something a little, yeah. I don't know. It looked like, when I first saw it, looked like it. Okay, that's the hard part, isn't it? Well, let's see here. If we put down, there's my -2, -1, 1, 2, 3, 4, 5. Let's see, I want a relative minimum here. So I could have a relative minimum right about here. I need an absolute maximum, let's say here, and an absolute minimum then down here. So what's going to happen in here? I can see myself doing this, okay, something like that. But what's going to happen here is we're going to have to come up and somehow make it a vertical there. If I could do something of a cubic root curve, then I would have that. Or, let's see.
Did you have it approach housing where you have to do zero? Because when that means zero is not differentiable.
Do what now? Oh, okay. So you're thinking about having an asymptote here?
Yeah.
Doesn't say that it has to be continuous, does it? So I'm trying to think because if we don't have that happening, then we possibly could do something like that. The other one I was going to show you though was it's called an inflection point. And if I come up, I don't know if I can do that or not, come up and then do something like this, where at this point I have a tangent line, but it is actually a horizontal at that point. That would be another way then of getting this, this drawn. So we have to have it undefined, or we would have this what we call a terrace point and an inflection point. And we'll talk about that. What? Thank you. Appreciate that. Okay, we'll let it go just a little bit longer. Okay, this first section is relatively short. There's only one other problem. Let's see if we can get this in before. It's called the honeycomb problem. I don't know that it's 68 in our textbook. That might have been from the other edition we had. But the surface area of a cell of a honeycomb is given by this. Now, you are not responsible for memorizing this at all, okay? That's just the way the formula is written. Where H and S are positive constants. That's important. H and S are positive constants. That means that 6HS, the derivative of 6HS is what? 0. Okay. And theta is the angle at which the upper faces meet the altitude of the cell. So theta is our variable. Find the angle theta in this interval that minimizes the surface area. Now, if we're going to minimize the surface area is our output, we're actually asked to find what? If I want to minimize the output, minimum would be an extrema. So we need to first do what? And we do that by taking the derivative, okay? Now keeping in mind that H and S are constants. So you're going to take the derivative of that, and when we minimize it, the second after we find the derivative, we're going to then do what? What were we just doing? Okay. That's the task. I'm not going to go through this problem because it is assigned for homework, but I did want you to know you don't have to memorize this formula. You're just going to use it. Pointing out that H and S are positive constants, so the derivative of a constant is going to be 0. Your input is theta, so you're going to have to, here's an S again, treat it as a constant, but you're going to have to focus in on theta. And then once you do that, you're going to set your answer, your derivative, equal to 0, and then solve for theta. And that will tell you then an extrema. Now, is that going to be the maximum? That